All right, this is lecture 4, chapter 6 for our robotics. We're going to do first part of hands-on here with our Phanex. All right, so we're going to power up and move the robot. We're going to call it jogging, but essentially you're just going to be able to do some basic movements with the robot. All right, so first method, being able to power it up, power it down, jog and joint. We're going to talk about what the differences between joint and world are, and the axis limits. We're going to talk about mastering the robot. We are not going to master the robot, but the importance of mastering and what it really means. All right, so the startup method, this is the one that we're going to use 99.9% of the time. In here, it's just the cold start method. So you're going to literally walk over to the Phanex on the controller, and the picture in the bottom left-hand corner, you're going to flip it to on. You're going to hear everything fire up. And that's kind of like the main power on. It's like turning on your computer, essentially. All right, so it's gonna initialize changes to the system variables. It's gonna update all the I/O. All right, and it's gonna just you have to wait a second, watch it boot up. But literally, it's just like your computer booting up. All right, another startup method is called a control start. It's not commonly used. I use it a lot more often than you ever will because I back up and restore all these. So at the end of the semester, when you guys are done, I restore the original image of the robot back on it. So anything that might have changed or screwed it up does that. And when you're doing that, there's some controlled starts that you go through in there. So it's not going from like ground zero, and it's kind of like just like opening and closing your program and restarting it or something like that on your computer. Okay, so when you're only going to do a controlled start when you're already powered up, sort of thing, and you're restoring the files or that sort of thing. All right, to activate it, all right, you hit previous and next on the teach pendant at the same time. It's always a test question. All right, so that's how you do a controlled start. It's by hitting previous and next. Okay, so we want to cycle the control power, so we're going to hit function and next. So remember, hit the function button, and then the two arrows on the teach pendant left and right, those are going to be, the one looks like a door, so that's like previous, and then you have the next. So you're going to hit next, and you're going to go over to the next screen, and you're going to go down to number 8 where it says cycle power, and you're going to hit enter. All right, this is just cycling control power. That's something that's not rebooting the system, so we don't have to like turn it on and off and doing that sort of thing. Okay. So you're going to do a couple labs. First lab is literally just powering up the robot and doing that sort of thing. All right, so let's talk about the different jog adjustment speeds. Okay, we have 1% up to 100%, and then we can go fine and very fine. Notice the difference between the two. All right, very, very, very small amount of movement. So with that, that's going to be when we want to get in really close and we're adjusting something. So when we get in and around a workpiece, all right, we're going to control it so we have very slow movements of the robot, so we don't accidentally like move quickly and break a piece of equipment or damage the tool head, things like that. So it's about our speed. Okay, when we're at 100%, we're running full speed, 2,500 millimeters per second, very, very fast. And then we're going to gauge that down. You guys are going to play with that, the speeds and things like that as you move the robot around. You're going to see if you're at 1%, we are moving very, very slow. And then you're going to hit, notice what's circled on the pendant down there, the up and down buttons. So if you just hit it up and down, you're just going to do a little bit at a time. If you hit shift and up or down, okay, you're going to get larger increments of speed increase. So you want to get back up to 100% real fast, you're going to hold down shift and up, or if you just want to move up just a little bit. Sometimes you guys are going to kind of have to fine tune it, okay, because you're going to get some DCS speed error and hit something. So you're going to want to make sure that you slow it down and you are within the dual check safety, right, the DCS speeds, so we don't do that, okay. The different coordinate systems that we're going to have, all right, and they've on the screen here you can kind of see where the coordinate button is. It's bold, all right. There's also a shift command that goes with that as well, so that'll change different frames for you as well. There's user frame and tool frames, and those different things that we're going to learn about as we go through there. But the coordinate system, that's going to tell the robot how it's moving. Okay, so the coordinate systems that there are joint, world, tool, user frame, and jog frame. And we're going to go through each one of those. But one thing that I want you to know in your head is jog in joint, record in world. Okay, when we're jogging in joint, all right, we're essentially, or even if you're moving the robot, you're moving one axis at a time. And that's the easiest one for us to do. If we get into an error, all right, we got to jog out of it. So if you slide the robot and hit the cage, or you hit the safety glass, things like that, you're going to get an error, all right, a fault. You're going to have to reset your fault, and you're going to have to jog it back out. But we do all of our movements in jog, or in joint, sorry, we're jogging in joint, and we're going to record all of our actions in world, because world, when world moves, all the axes move at the same time to get to one location. Joint, we are moving a single axis at a single time. That's easier for us to get to a specific point, all right? But when we record and we want the program to move in a nice smooth motion and automatic, all of our points need to be recorded in world, okay? So when we jog in joint, all right, we're going to stand behind the robot and get our frame of reference of where our X, Y, and Z is. Okay, but taking a look at this, we have axis 1, right? So that's J1 on the teach pendant. And notice it has the two teach pendant buttons there. There's minus X and plus X. So really, you're just, remember we called that one the waist. The waist. So it'd be like you standing up and twisting your waist right or left, all right? Then we have axis 2, all right? Remember we called that one our shoulder, raising and lowering the robot. So that's J2. And notice that's our Y coordinate. So we have a positive Y and a negative Y, all right? So that's all directions. And remember what keeps track of these? The servos. And they come from base 0, which we're going to talk about when we get to mastering, all right? The next one, remember we talked about, is the elbow. The elbow is axis 3. That's moving our Z, okay, up and down. That's J3. So you're going to hold down shift when you're doing all these, and you're going to jog in joint. Always jog in joint, record in world. I'm going to say that 1,000 times, and we'll still get some issues when we do this. All right, then we have, okay, we start rotating our axis. So axis 4, this is where we are rotating around the x-axis. So before the first one, right, J1, where we're doing our waist movement, we're actually moving on the x-axis. We're moving left and we're moving right based on the x-axis. Now, in axis 4, we're rotating to the left or the right about the x-axis. So if you look at the very bottom of the robot, there's an X, Y, and a Z coordinate system. And if you notice, J4, axis 4, rotates around the X coordinate system. All right. Then we have J5. That rotates around the Y coordinate system, or around the Y axis, I guess I should say, not coordinate, but the Y axis. So we can see the direction at the bottom of the robot where the Y axis is, and we are able to rotate the robot around the Y axis. And lastly, J6, we are going to be rotating around the Z axis. So if we look at the coordinate system, Z is the one that's going straight up and down. We are rotating, okay, the wrist of the tool there around the Y, or I'm sorry, around the Z axis. Next, this is the world coordinate system, all right? And we have our center of origin, which is 0, 0, 0. And when you master a robot, that's for the servos and everything as it keeps track of the coordinate system. This is where it identifies as 0x, 0y, and 0z. And then we move up and down from there. And we're going to master the robot and look at the witness marks so you can kind of see, so it knows where minus y is, minus z, minus x, or plus x, plus y, plus z. All right? So this is predefined when we're in world frame with the robot. All right? right, so we take a look at this. How is our frame of reference? We use what we call the right-hand rule. So we're standing behind the robot, and if you put your right hand out and make what you see on the right-hand side here, positive X is forward, positive Y is to your left, and positive Z is up. So you always do that frame of reference from behind the robot. All right, so even if we see, okay, positive X, positive Z, let me back up a couple slides here. Even if we go back where joint is, right, positive X is facing the front of the robot, positive Y, and then positive Z is straight up. So it's the exact same here. The frame of reference here is from behind the robot, just like the frame of reference here is from behind the robot. All right, so we'll be using the right-hand rule. So world frame, okay, there's a coordinate system to actually get to the end of arm tooling. So all the math that you learned in algebra, the Cartesian coordinate system, where you had an X and a Y, well, now we have X, Y, and Z, but that's actually the location of the end of arm tooling. So when we keep track of where the coordinates are, it's based on the end of arm tooling and how far away it is from 0, 0, 0. Remember, 0, 0, 0, that's shown here where all the axi come together, right, at the middle kind of back portion of the robot, or it's probably at C of G, CG in that aspect, okay? So everything, all the coordinates are based on the end of arm tooling in world coordinates here. Remember, these all apply. J's apply in joint, X, Y, and Z's apply in world. You'll still move those, all right, to do joint. But when we do world, what this is saying, joint is individually moving an axis. World is moving the X, Y, and Z axis at the same time. So this slide's a little confusing. It's not that you have to hit X, Y, and Z at the same time as you're holding shift. All right. What happens is you move the robot in joint. You record a point. When you record a point, it records the X, Y, and Z location. And then you move the robot in joint again, and you record a point, and it records X, Y, and Z location. When you switch to world coordinate, in order for the robot to get there, it doesn't move one axis at a time to get to that point. It moves all the axes it needs all at one time to get to that point. So that's really what the difference is between jogging and joint and jogging and world. You're not hitting the X, Y, and Z, but the X, Y, and Z axi are all moving at the same time to get to the point. Okay, J is joint is only moving that specific axis. So there is a difference, okay? And you'll notice when you try and move the robot in world, it's going to twist and do all these funky things to you because it's trying to get to a common coordinate. All right, the minor axis in world, okay? These are more like our airplane frames of reference. But, however, it's still using the right-hand rule. We're going to rotate around X, rotate around Y, and rotate around Z. More commonly, though, we call it the yaw, the pitch, and the roll. All right, so yaw, this is more airplane terminology, but it's the yaw. We're going to rotate around the x-axis. Remember, the x-axis is the one that's coming straight at you. Okay, if you're standing behind the robot, it's coming straight out of the front of the robot, and we're rotating around the x-axis. Okay, so that's your yaw. So if an airplane, it's like banking left, banking right if you're in an airplane. All right, the pitch is rotating around the y-axis. All right, so the right-hand rule, your middle finger is pointing to the left, that's the y-axis. You are rotating around that. Okay, that's called the pitch. Okay, so for your airplane, I'm just trying to give you a good analogy. For an airplane, when we're talking about pitch, we're either raising or lowering the nose of the airplane. Raising or lowering the nose of the airplane, we're going around the y-axis. or the jets and back drop. Same kind of concept. Okay, so we got yaw, pitch, and then the roll. Okay, the roll is rotating around Z. So remember, in our right hand rule, Z is your thumb, and that's going straight up and down. So imagine you're rolling, okay, around Z. Roll around Z. So if you put your right hand up, all right, and make the right hand rule with your X, Y, Z, your thumbs up, take your other hand and literally roll around the Z. That's exactly what you're doing. So that's like when an airplane, okay, is going to roll around its center of gravity. We got to change headings and do that sort of thing. You're not always going to yaw and bank, okay? So that's where the roll comes into play. So yaw, pitch, and roll. Commonly used for those type of rotations around axi. Okay? So the position, I can't speak, sorry about that. The positional data, we present it in 3 different ways. Joint, which is how we're going to jog it. User, which is something that you would define. We're not going to do a lot of stuff with user frame jogging and that sort of thing. And then world frame. So we're going to jog in joint and record in world. Now what you guys are going to do in the lab is you're going to hit the POSN button, which is the position. And that's going to show you the exact location of the end of arm tooling. So when you hit this, all right, we're going to hit menu and position. And then notice it's going to tell us what coordinate system we are in. We are in world. Okay, so world is what's shown in green. Okay, it will not show you world and joint at the same time on the screen here like this. So anything in world is in Cartesian coordinates, X, Y, Z. Okay, yaw, pitch, and roll are in degree in that portion. Okay, then joint, we're going to see joint is in degrees. Okay, so world is in millimeters. All right, the robot's entirely based on millimeters, its speeds in millimeters, and everything along those. But those are distance from the end of our tooling. So if you can look at the picture of the robot, okay, towards the back of the robot, remember where we talked where 0, 0, 0 was? You can see an X, Y, and a Z there. Then the robot, the very tip of the robot, the end of arm tooling where the little green like tennis ball kind of is cut in half sitting, that's the actual location when X is 1917, Y is 331, and Z is 810. That's the exact location in world coordinates. If we were in joint coordinates, all right, those are in degrees. So it has moved 9 degrees, okay, in J1. Does that make sense? And J2's moved 18 degrees. J3's moved -9 degrees. J4, J5. So essentially you're moving degrees from 0. That's really kind of the difference between the two and how they store it. Okay, and you can click back and forth between joint and world on the screen. This is relevant because if you're writing a program and you know where you need to go, or we're going to talk about program adjust later, okay, same kind of concept, you can easily make an adaptation to X, Y, or Z knowing where it's at. All right, so world is based back here, right? That's where 0, 0, 0 is, and that's where the actual location is, all right, end of arm tooling, the half tennis ball piece. So if we lay it out, that end of arm tooling has gone in the X direction, Y direction, and the Z direction based on the components that you have there, okay? So joint reputation, okay, it's angles for each axis. We talked about this. Now what we're going to get into is witness marks. Those are inscribed on the arm, and those are where the 0 degrees are for joint. Okay, so remember, world is predetermined. It's kind of the back end part of the robot. But joint is determined by where the witness marks are. And we'll walk up to the robot. There's a lab where you have to inspect the witness marks, and part of your lab is to move the robot to all the witness marks. Okay, we're going to be a little bit harder on the LR mates, those witness marks. I tried to mark them a little darker, but some of them are literally just kind of scratches in the paint where the witness mark is. They don't actually have the witness on there like the large robot does. But you'll see kind of the difference when we walk up and start looking at the robots, and I'll show you the difference on both robots. So what we want to do, all right, and this kind of relates back to the DCS as well, is we define access limits. So what's that do? That's controlling the motion of the robot. You want to restrict it because of different work area limitations. So for us on the big robot over in the cage, we have a camera. I want to restrict the access limits there because I don't want you guys taking the camera off. All right, that's expensive to replace, and that robot will destroy that thing in a heartbeat. Okay, so we want to restrict the work area so that we don't damage things and we can move around different fixture points and things like that. So we can do access limits on X, Y, and Z. We also have limit switches that control us. So that robot cannot spin all the way around anyways because we have limit switches that define that as well. All right, so for us, we have limit software. Okay, that's what's going to be built in. Well, our DCS, right? So we can do that. Now, the purpose we have access limits. Okay, this is a test question. The purpose we have access limit, avoiding hard stops and over travels. That's the entire purpose of having access limits here. Avoid hard stops and robot over travels. And also working around equipment, but that's one of the big things there that's on the test. All right. We can use the limit switches, like I said, and I'll show you those on the bottom of our large robot. They're sitting at the base. That way, no matter what, it can never hit the cage on the one side, or it will never hit anybody standing in the back corner when it's going. All right, we can do hard stop. What's a hard stop? Well, hitting the E-stop, okay? That's a hard stop. So if we do access limits, it knows that it's getting close to that limit, so it'll automatically slow the robot down and stop it there. Versus you hitting E-stop where we do a hard stop and everything has to shut down like instantaneously, okay? So that's all tied to our DCS. So we can do speed and position checks in order to, and you know, it saves the wear and tear on the motors and the servos because they have the built-in brakes. All right. So how do we set those? Okay, I don't want you guys like really messing with it because on the big one because I have everything predefined and I don't want to hit the camera. Okay. So, but essentially, how do you get there? You hit the menu button. You go next, system. We can go type, and we're going to set the access limits. All right. So why do you want to do this? This is how you control your working envelope. Because if you don't need the robot to swing open in a big space, then don't do it. Confine it down. Plus, remember, there's no need for wasted space, and you don't want someone to be able to walk into that space and get clocked while something's being produced. All right, but we can look at the different access limits here, and we can inspect them. All right, in one of the labs, the access limit that you're going to mess with, all right, is I'm going to have you change the Z. And you can change the Z so you can see how far up you can extend the robot. I'm going to have it set at a specific height. Okay, in one of the labs, you're going to go in and you're going to change the Z value so that the robot can't go as high or it can go higher, and then you're going to change it back to what I had it set at. All right, so that you're going to be doing this in one of your labs. You're going to be changing the access limits, but I only want you changing the access limits on the Z axis, okay, so raising that up. So when we talk about mastering, hey, we're gonna go look at the witness marks. We can see them really big on our big robot, not as good on the little robot, but I'll show you on both because it's important that one of your labs is you're gonna line the robot up based on all of what we call the witness marks, okay? So each joint is in a certain set position, all right? And we're gonna master the robot. Why do we do that? Okay, so that it knows where home is. When we master the robot, it's telling that end of arm tooling that that's where 000 is. If we don't do this, or if it's mastered incorrectly, it can be very dangerous because the robot can be moving in the wrong direction. All right, so this is where you have to define as user. Now, you guys aren't gonna master do any mastering in this lab for your certs or anything, but I'm already going to have these pre-mastered to how I want them set for you guys. But mastering is aligning the robot to all the witness marks. So your part of the lab is you're not going to go through the mastering procedure, but you are going to move your robot somewhere into the cage, and then I want you to jog it so that all the witness marks are lined up. and we're going to go in specific places. Now, what's this slide showing? This is showing where the witness marks should be. If you were to go over and walk over and look at the robot, you should be able to see them in these specific locations. It is slightly different on our little LR mates. But on our big one, okay, not every axis has this, but this is what we're looking for. All right, see the little gauge here, 0 degrees. So you want to make sure that those marks are exactly lined up, that middle mark right there. So that's exactly at 0 degrees. Now, when they come from the factory, they do tend, I mean, if it's not built in, they're going to put those witness marks in. Does that mean that I can change where I want 0, 0, 0? I can. Yes, I can master it to go a total different direction if I wanted to. All right, I think one of the ones in the card's mastered totally differently than where it actually sits in its home position. Okay, you can, but for the most part, when you master the robot, you set this to 0, 0, 0, so it knows that this frame of reference, this is where home is. And that's very, very, very important. All right, so for you guys, all right, that's it for this part of the lecture. This is where you guys actually get to start having a little bit of fun. Okay, you're going to go do lab 1, 2, and 3. The labs are laid out at the end of chapter. All right, so remember, this is chapter 6. So you're going to go to the end of chapter 6 and read through the lab. Now, the lab might point you to like 6.3. You're going to have to turn back through chapter 6 and look at 6.3 and see what's going on. All right, I need to see everyone do all of their labs and check you off. So it's not a, yeah, I did it. It's a, I'm going to come over and watch you. So obviously the power up one's pretty easy, but I'm going to come over and I'm going to watch you, make sure you're in joint, and make sure that you can move the robot around. All right. Then I'm going to watch you change the coordinate system, put it into world, watch you twist the robot around. All right. I want you to alternate between quick and full menus. I want you to leave it in full menus when you walk away or hand off the pendant to the next person. Okay. Then, lab 4 is extremely important, especially on the large robot. We're going to verify mechanical 0. That's where the mastery witness points are. You will be walking inside the cage with the robot. All right, because you're going to have to move it to get it into the right points. And sometimes you can't see those points unless you're up close, and you got to get up close and personal. When you guys do this, okay, if you are in the big cage robot, I am there with you, and you are the only person, remember, that gets to go in the cage and control the robot at the same time, only in T1, with the teach pendant in hand, is the person controlling the robot. One person in the cage, only one person, and it's whoever has the teach pendant. And you will walk in there and you will move the robot to mechanical 0. Okay, I'm probably going to have everybody do this on the big robot as well, because you got to be able to go in there, and it's a little scary, but it's important that you're able to, I want you to respect what that thing can do to you. All right, that way you'll be a little bit more cautious. Okay, it will be safe, because remember, we're going to be in T1. So, like, seriously, it'll be like one of those movies where you're running in slow motion to get away from something and it's coming super slow at you to get you. You will never be in that position. You're not going to get damaged or harmed or anything like that when we are in the teach position. Okay? When we are in T1, you will be okay. All right? Because you're going to have to be in there and move it and line up the witness marks. But, so, that's that. I think you guys are going to get excited, start getting some hands-on movement with the robot. All right? And then we finally get to take it to the next level after this. So remember, this is the end of chapter 6. This is where the labs are. You each need to do lab 1, 2, 3, and 4, and I have to check you guys off. I want everybody, we'll kind of rotate around. Everybody kind of rotates between the little robots and the big robots. As far as I want you to be able to see where the witness marks are and putting it in the mechanical 0. All right, remember though, what I want you to do, here's the biggest hint. When you're going to mechanical 0, make sure that you are in the, you want to jog the robot in joint. So make sure you're in the joint coordinate system. Don't be in world. It will be really challenging for you sometimes to move and get to the witness points. Okay? We will see you in lab.